Hi everyone, today we are discussing solving quadratic equations. We are going to take the factors that we used in the prior unit and change those into zeros, which are also called roots or x-intercepts. So first off, we want to remind you what is the quadratic equation, and that is down here, y equals x squared plus 2x minus 15. So remember, the quadratic is any equation with a power of 2. Now, factors are where we actually factored this down. So when I find the factors of this, we found x plus 5 and x minus 3, okay? In order to find the zeros, x-intercepts, roots, solution, what we're doing is setting each of these factors equal to 0, okay? So if I took x plus 5 and I set that equal to 0, I get negative 5. And if I set x minus 3 equal to 0, I end up with 3. So this is where the negative 5 and the 3 come from. So the factors are x plus 5 and x minus 3. The zeros are negative 5 and 3, okay? Because x-intercepts and roots and solutions are all the same thing as zeros, you can see they all are negative 5 and 3 here, okay? So over here, we're going to take and try a couple more. So given factors, find the roots. So if we had x, sorry, I'm going to try to thicken this up just a little bit. We had x minus 2 and x plus 6. So that means I would have each of these equal to 0. So therefore, this would be the number 2 and the number negative 6. If I had x plus 3 and x minus 1, once again, I set them equal to 0. So therefore, I would have negative 3 and positive 1. And once again, okay, I would have 0 and negative 5 over here. Okay. All right. At the bottom, it says, given the zeros, write the factors. So you can see when I look at the factors from up above, I had x minus 2, the answer was positive 2. If I had x plus 6, the answer was negative 6. So really, they're just backwards from each other. So if I had 2 and 4, that means I have an x minus 2 and an x minus 4. Okay, 6 and 0. I have an x minus 6, and then I just have x. You do not put 0 there. Okay, so for negative 3 and 8, I have x plus 3 and x minus 8. So they're just backwards. Negative 1 and negative 5, x plus 1, x plus 5. So very simply, from factors to zeros, they're basically changing sign, okay? But you need to set them equal to 0. All right, so here it says all factoring, we factor, set equal to 0, and then solve. So in this first example here, you can see that we have 4x, x plus 1, and x minus 5 equals 0. This is factored form, okay? All the factors are already done for you. So I set each piece equal to 0, as you can see here, okay? And then solve. So 4x equals 0 becomes x equals 0. X plus 1 equals 0 is negative 1, and x minus 5 equals 0 is x equals 5. Okay? All right. If I wanted to know if that was right, I could take and actually graph this in Desmos. So check your answers using a graph. Graph it in Desmos. We are looking for the x-intercepts here. X-intercepts. Okay, that's what these zeros are. Zeros, roots, solutions, x-intercepts, all the same thing. Okay, so over here, I would have X plus 4 is equal to 0. 2x minus 5 is equal to 0. So this gives me x is equal to -4. But be careful, it's not just 5. Now we have 2x equals 5, and x is equal to 5 halves here. So be very careful. Same thing with number 2. 2x minus 1 equals 0. We should find that x equals a positive 1/2. 3x plus 6 equals 0. Okay, so 3x is equal to -6. X is -6/3, which is -2. So you always want to simplify down. On the third one, 2x equals 0. Well, that's just going to be 0. X plus 12 equals 0. And that's just going to be -12. Okay, so you're always setting the pieces equal to 0. We can also do factoring. So our first set of factoring here discusses when we are using the GCF and or doing difference of squares. Okay, same thing, factor, set factors equal to 0, solve. So if I had 2x squared minus 32 equals 0, it has a GCF of 2, I pull that out. And now I factor the inside, x plus 4, x minus 4. Now, when I put 2 equal to 0, 2 is never equal to 0. So you can see I put a big red X there. That means that 0 is not the solution. It means that that doesn't give me a 0 or a root intercept. So we're going to throw that away. Okay, there's no X involved there. Okay, x plus 4 equals 0 gives me -4, and x minus 4 equals 0 gives me +4. So the only two valid solutions here are -4 and +4. Okay, I can do the same thing over here on the side. Okay, and you can go through, if I factor out a 7, x squared minus 7x equals 0. Oh, I'm sorry, I needed to take that x out. Let me start this one again. Sorry about that, I didn't see the x. So our GCF is 7x and x minus 7. So 7x equals 0, x minus 7 equals 0. So my answers are 0 and +7. Same here, x plus 4, x minus 4. So we have -4 and +4. Okay, so now I'm looking here. Now I'm looking at 50. That's not divisible by 8. So I have to say, well, what number is divisible by 8? I can have a 2. So 2x, and that gives me 4x squared minus 25. So I have a 2x, and then I break this down with difference of squares. 2x plus 5, 2x minus 5. So when I set them equal to 0, I should have 0, a -5 halves, and a +5 halves. All right, number 4, bring that 81 to the other side. So 36x squared minus 81 is equal to 0. Perfect squares here. Okay, so we have 6x plus 9, 6x minus 9. Okay, now notice I've still got a GCF in there. I could pull them out now, or I can just wait and solve at the end. If I set it equal to 0, I would have x is equal to a -9/6, and I can just simplify that. Okay, they're both divisible by 3, so a -3 halves. And I also would have the positive of that, which is +3 halves. So you can see if you do forget to factor it out, when you're solving, you just have to simplify in the end.